In this random experiment, 5 fair coins are tossed. Therefore, the size of the sample space S is 32 because for each coin there are two possible outcomes, either head or tail. So since there are 5 coins altogether, the size of the sample space is 2 to the 5, which is 32. Let x be the number of heads that turn up. We first count the probability that x equals to some fixed number k, where k is between 0 and 5. So if k equals 0, then this is the probability that no heads actually turn up in the outcome. So in general, suppose x equals to k. What is the probability that we'll get k number of heads? Well, there are 5 coins altogether, and we want exactly k of them, right? We want exactly k of them to be head. So the number of choices is 5 choose k. So the total number of outcomes that have k number of heads is 5 choose k over the size of the sample space, which is 32. Next, we want to compute the probability of having at least one head. The complement of this event is that there is no heads in the outcome of tossing the 5 coins. Since the event and the complement sum to 1, the probability here is 1 minus the probability of the complement, which is the case when there is no head in the outcome. This probability can be computed using the formula we had previously. So this is 1 minus 5 choose 0 over 32, which will give us 1 minus 1 over 32, which is 31 over 32. What about the probability of having at least 2 heads? Well, the complement of this event is that we have at most 1 head. So this probability is 1 minus the probability of the complement, which is the case when x is at most 1. We know that x cannot be negative, so either x is 0 or x is 1. So we can compute this probability by computing the probability of x equals 0 and when it is exactly 1. Again, by using the formula we obtained previously, we can compute this as follows. When x equals to 1, we have 5 choose 1 over 32. So after simplification, this will give us 26 over 32, which simplifies to 13 over 16. Using the results we previously obtained, we are now ready to answer the questions in part A. Here we want to calculate the probability of having exactly 2 heads, given that at least 1 head turn up. These events can be expressed in terms of x, because x denotes the number of heads. So we have the probability of having x equals 2, which means exactly 2 heads turn up, given that at least 1 head already turn up. By the definition of conditional probabilities, this is equal to the probability of the event x equals 2 intersection the event x at least 1 divided by the probability of x being at least 1. What is the intersection of the event x equals 2 and x at least 1? Notice that x equals 2 implies x at least 1. So the intersection is just the event x equals 2. In terms of the Venn diagram, we know that if the set x equals to 2 will be sitting in entirely in the event at least 1. So the intersection is just the event x equals 2. But now we know how to calculate these probabilities. If we substitute k equals 2 in the formula, we have 5 choose 2 over 32 for the numerator, and in the denominator we have 31 over 32. So we have final answer as 10 over 31. For part B, we want to find the probability of having at least 2 heads, given that at least 1 head turn up. Again, we can write this in terms of x. So having at least 2 heads means that x is at least 2. Given that at least 1 head turn up means that x is at least 1. By the definition of conditional probability, this can be written as the probability of x at least 2 intersection the event that x at least 1 divided by the probability of x being at least 1. Again, what is the intersection of x at least 2 and x at least 1? Notice that the event x at least 2 implies the event x at least 1. In other words, the event x being at least 2 is a subset of the event for x at least 1. So we have the probability of x at least 2 divided by the probability of x at least 1. Right, because the intersection of these two sets is just the set x at least 2 itself. We know these probabilities from our previous calculations. So the numerator is 13 over 16 and the denominator is 31 over 32, which will simplify to 26 over 31.